So here we have an exam question on density, which is quite unusual. The density of gold is approximately 19 grams per cubic centimetre. We're told. So grams per cubic centimetre is the units for density. And what we've also got here, we could say, is a rate. So 19 grams per cubic centimetre. We normally think of rates as a length or some other sort of measurement per, and then we have a time value, seconds or hours or whatever. But in this case, with density, we've also got a rate. It just happens that it's per cubic centimetre. Okay, so how do we answer a question like this, and how did others do when they attempted it in the GCSE exam? Well, apparently a variety of methods were used, and generally the question was very well answered. Few students, though, didn't check all three items. Now, how do we think about a question like this? Well, if we recognise that rates are ratios and that item A has these two ratios that we can use to measure the approximate density, then it's just a question of whether we're going to compare the volume to the mass or the mass to the volume, so we can do it either way. But either way, we're going to find that if we call this our x term and this our y term, that x is directly proportional to y. In other words, if you scale up x, you're also going to scale up y. And that means, well, you can think about this as a constant of proportionality. So the constant of proportionality, let's say y, is going to equal the constant of proportionality k, some scalar, times x. So the relationship is going to be like that. And therefore, k, the constant of proportionality, if we want to work that out, we can use this given ratio here, this rate, 19 grams per cubic centimetre, we can work out the constant of proportionality for that, which is going to be equal to y divided by x. So in this case, y is 1 and x is 19. So k is 19, and if these share the same constant of proportionality, if they scale up by 1/19, then we'll know that they might be the gold that we're wondering is inside these packets bought at a car boot sale. Okay, so the density of gold is approximately 19 grams per cubic centimetres, which gives us a constant of proportionality of 1/19. Let's try these. Item A. Well, we've got 2 divided by 9.5. Is that the same constant of proportionality? If I want to simplify this fraction, I have to double the bottom so that I just get an integer at the bottom. So if I double this, I'll end up with 19 as my denominator. So at the moment it looks like it, but I also have to double the numerator. So 2 times 2 gives me 4. So we can say that A is not, so cannot, to use their terminology, cannot be gold. Okay, so have a look at B. B is 3 cubic centimetres compared to 57 grams, and that does simplify to 1 over 19. C is 4 over 76, and that too gives us a constant proportionality of 1/19. So these could be gold, but A cannot be gold, so that's our answer. A cannot be gold. Now that's one way to look at it, but perhaps a slightly overcomplicated way. And when I do a little check here, by thinking about it in a slightly different, just from a different direction, then hopefully you'll see that it can be done slightly simpler. So I suspect a lot of candidates just did this. That if we think of this instead as we do with the rate, 19 grams per cubic centimetres, so in this direction 9.5 to 2, or in this case 19 to 1, because this is per 1 cubic centimetre, then in other words, if we've doubled the number of cubic centimetres here, then if we divide that into that 9.5, then we'll actually get the density of this item A. So for item A, we can say 9.5 divided by 2 equals half of 9.5, 4.75 grams per cubic centimetre. And I think that's maybe a simpler way of thinking about it. And since it is 4.75 grams per cubic centimetre, it is not anywhere near 19 grams per cubic centimetre, so it cannot be gold. Okay, let's have a look at item B, again comparing the mass and the volume and seeing whether the ratio is the same as the rate. Here is the same as the density for the density of gold. So of course it's the reciprocal of what we had before. It's 57 grams per 3 cubic centimetres, which gives us a simplified, just a division or a simplified improper fraction. 57 anyway, divided by 3 gives us 19 grams per cubic centimetre. And also with the last one, item C, we've got 76 divided by 4, which again gives us 19 grams per cubic centimetre, which is approximately the density of gold. So by reversing the direction there of the ratio, we've given ourselves a little check so that we know that this result gives us the right answer.